Well, radiation can be useful. We can take advantage of this to help us understand or figure out how old things are. And this is called radiocarbon dating. And you may have heard of this. We can estimate the ages of different things using radiocarbon dating. This only works for things that were alive at some point. It doesn't work on rocks. It only works on living organisms. If you made a scroll out of papyrus, the papyrus was alive at some time, and so you can use radiocarbon dating on that. If you're looking at a cotton garment, the cotton was alive, right? But, you know, a gold bracelet was never alive, and so radiocarbon dating isn't going to work. And we can do this because of the presence of radioactive carbon-14 in the environment. Carbon-14 is continually being formed in the upper atmosphere. Neutrons from space and other places, I guess, are bombarding nitrogen. And when that happens, carbon-14 is created. That carbon-14 decays back to nitrogen by beta emission, and it has a half-life of 5,730 years. So because it's always being created and it's always decaying, there's a relatively constant level of carbon-14 in the atmosphere. So it's nearly constant. That carbon-14 gets oxidized to carbon dioxide and gets incorporated into plants by photosynthesis and makes its way up the food chain. So if you have carbon in you, you have carbon-14 in you. Does that bother you? We're all radioactive. Ah! It's okay. You've always been radioactive and you just didn't even know it. All living organisms have the same ratio of carbon-14 to carbon-12 as that which is found in the atmosphere. Because you're taking carbon in and you're also excreting carbon. And so there's this constant changeover. And so the ratio of the radioactive carbon-14 to the non-radioactive carbon-12 is the same in your body as it is in the atmosphere. And that is true for every living organism. That ratio is the same. What happens when you die? You stop taking in more carbon-14. But the carbon-14 that was in you when you died is still decaying. And so as your body rots in the grave, the carbon-14 continues to decay and the level of it goes down. So we can look at the ratio of carbon-14 to carbon-12 and estimate how long you've been dead. Isn't that, so cheerful? Right before Christmas. It's very, very cheerful. The maximum age that can be estimated is 50,000 years. If it's older than that, radiocarbon dating isn't going to help. And that's because the level of carbon-14 present in a sample that's older than 50,000 years is so low that you can't accurately figure out how much is in there. And they know that this is accurate because they can check it against objects whose ages are either known from historical sources or from other methods, like counting tree rings in the trunks of old trees. You know, a tree grows a ring in its trunk for each year that it was alive. And they find there's a deviation of up to 5%, and that's due to small variations in the atmospheric carbon-14 levels over time. It's pretty accurate. So something that has been dead 0 years, the concentration of C14 relative to that in living organisms is going to be 100. After 5,730 years, it's going to be 50%. So this isn't really going to be a good technique to find out if this gangster was killed on Tuesday or Thursday of last week, right? That's not going to tell you anything like that. After 34,380 years, there's only 1.563% left. And you may encounter questions in the homework or on the final exam about this as well, but again, it's going to be pretty straightforward types of questions. So here's an ancient scroll is claimed to have originated from Greek scholars in about 500 BC. A measure of its carbon-14 content reveals it to contain 100% of that found in living organisms. Is the scroll authentic?
No.
Is it from 500 BC? No. It's much more recent than that. Like if we go back to look at this table, it's probably very close to 0 years. You know, maybe it's 5 or 10 years old, but definitely not from 500 BC. What percent would we expect if it was from 500 BC? Well, how many years ago is that? It's 2015 now, right? And add another 500 years to that. So 2,615, right? So that's about halfway here. So we're going to expect 75%-ish, right? Just rough numbers. So the fact that it's 100 says no, not authentic. And not just that it's off by a couple of years, it's off by decades and decades.